So hopefully you were able to experience the illusion of the opposite color from the one that was actually on the screen. It's really interesting when that happens. Let's try another one. So just keep your gaze on the center of this oddly colored flag. You can blink normally, but just try and keep your eyes in the middle here. And keep looking. In a moment, I will advance. So hopefully that was a similar experience to the one you had with the video where you looked at the picture of the bee. We're seeing the same thing here. I like to use this image because it's a simpler one and it gives us a chance to identify some of the particular aspects of what's happening on with opponent theory of color. What we know is that if a person stares at a blue like this one, the after image they get after seeing that color is yellow. If they stare at black, the after image would be white. And if they stare at yellow, the after image would be blue. Right? So stare at blue, you get yellow. Stare at yellow, you get blue. So it's a two-way street here. In addition, there's one more set of colors that are opposite each other, red and green. You stare at either one and you'll get an after image of the opposite. Stare at red, you get green. Stare at green, you get red. So it turns out that there are 3 channels for these opposite colors. And so we have the red-green channel, the blue-yellow channel, and the black and white channel. Although the black and white, of course, is not a color, but it still works in the very same way. Trichromatic theory cannot explain our experience of these color after images. And so we have this additional theory called the opponent theory of color perception, and it just says that colors come in these opposite pairings. And again, the channels are red versus green, blue versus yellow, and of course the black and white. But in terms of color, it's just these 2 channels, red and green, blue or yellow. And the idea is that a color can be one or the other, but not a combination of the 2. So we can mix green and yellow or green and blue and come up with these different shades. But there's no color that we experience that is a mix of green and red. There's no reddish green or greenish red. But we can imagine a yellowish green or a bluish green, right? Or a bluish red. So the opposite colors can never ever be mixed. We don't experience them like that. And that's because a neuron in the visual system fires one way. For example, maybe it becomes excited and fires more when the color is green, and then becomes inhibited when the color is red. In other words, it has an opposite reaction to these 2 colors. And it's essentially like tossing a coin. It's heads or tails, one or the other. It can never be both. But we can toss 2 coins at the same time and get a mix of the 2. And that's what happens then when we have like a yellowish red. The blue-yellow channel might be signaling yellow, and then the red-green channel might be signaling red, and we can get these combinations.